All right, welcome everyone. Today we're going to be looking at section 2.5, Intro to Scatterplots. Scatterplots, as you probably have seen them before, if you remember, are those graphs of plotted points that show the relationship. Sorry, I write too big. The relationship between two sets of data. So usually scatter plots, we use them to kind of compare two sets of data to see if there's a connection between our two values. For example, you could do a scatter plot with smoking and rates of cancer. Is there a connection between smoking and cancer? You could create a scatter plot to kind of visually see if there is a connection between those. A correlation is kind of a value or a way, or we describe the connection between a set of data and how strong it is. There's three main types we're going to see today. You can have a positive correlation. You can have a negative correlation. Or it's possible to not have a correlation. So you could have like none between the two sets of data. Maybe there isn't a connection between your height and your IQ or something. So there's not always going to be a connection between the two sets of data you look at, or sometimes it'll be stronger or weaker. But a lot of times if you're conducting a study, you might want to kind of figure out how closely connected are the data points you're looking at. A line of best fit we're going to see is a line that runs through the middle of your data. And we use it oftentimes to make predictions for like future values. For example, if I had a model or like a scatter plot of a population of the United States, maybe I could use my line of best fit to predict how many people there would be in the country 50 years from now. So basically what we're going to be doing with scatter plots in the future is we're going to be kind of collecting data and seeing if we can make accurate predictions based on a model we create. So these are just some vocabulary words. We're going to jump into 4 concepts today. These follow the delta math sections very closely, and all the questions, just so you know, today are pulled directly from delta math. So please kind of have this note sheet handy when you're trying the delta math assignment today or tomorrow. But the first concept we're going to look at is how to draw a line of best fit. So basically a line of best fit, if you remember from the definition above, is a line that kind of cuts your data down the middle. It's basically trying to follow your data as closely as possible so you can make predictions. Like I said, that's what we'll be doing with these in the future. So the big idea here is we want to draw a line, like I said, that cuts your data down the middle. So there should be a relatively equal amount of points on both sides of your line. It doesn't have to be perfect, but you're just trying to get as close as you can eyeball. So we're going to do this first one together. So like I said, we're going to just pick 2 points. And like I said, I want to cut down the data down the middle. So for example, I might put my first point here, my first point here-ish. If I connect these, kind of cuts it down the middle. It's not perfect, but if you look, there's a similar amount of yellow points on both sides. I'm not going to count them, but I bet it's not that far off. And like I said, delta math is a little forgiving as long as you're relatively close. See if you can draw the line of best fit in this second scatter plot. All right, assuming you gave that a try. Yours could look slightly different than mine, but I might put my first point down here and up here, and then I slice it down the middle. And like I said, I'm not going to count the yellow dots, but it looks pretty close. Not perfect, but not too bad. And like I said, I like to put, if you notice, I like to put my points kind of on both ends of my data set, but it doesn't really matter where you put your points as long as when it connects, it slices through. And delta math, it's going to connect between the 2 points you pick automatically. So you don't have to like draw your line very active. Like it's not like you have to make sure you're using a ruler or anything. But like I said, eventually we'll learn new methods to find this line of best fit other than just eyeballing it. We'll probably do that next week, but I just want you to understand what a line of best fit kind of looks like, or the idea behind getting a line of best fit. So that'll be your first section in delta math. The second one we're going to look at is describing the type of correlation. So if you remember our definition of correlation from the front, correlation basically just describes the connection between the two sets of data you're looking at. Is there a positive connection between it? Like for example, the amount of food you eat might be correlated to your weight or something. If you're overeating, you might gain weight, or if you're undereating, you might lose weight. But a positive correlation basically means as your graph goes left to right, it gets bigger, your Y value increases. A negative correlation means as your graph goes left to right, it goes down. If you kind of think of a slope, if you have a positive slope, you have a positive correlation. If you have a negative slope, it's a negative correlation. If your points look all over the place, or it makes like your line of best fit would be like a horizontal line, that would be no correlation. So and the difference between like a strong or a weak or a high and low is how close your points are to your line of best fit. If you kind of look at the difference here, see how like these points are all pretty close to my line of best fit. But in this one, see how the points are a little bit more spread out. That's the difference between strong and weak. So if your points almost make a straight line, that's very strong. If it's kind of spread out, not making a very good line, we would say that's more of a weak positive correlation. And the stronger your correlation we're going to see in the future is probably the more accurate your predictions will be. Like the stronger your correlation, that's suggesting that there is a strong connection. If it's weak, it might be connected. It might not be as big of a factor. There might be other reasons that are causing your data to kind of be the way it is. So let's just look at a few examples. So these are, like I said, all from Delta Math. There's going to be a drop down where you can pick different choices. So this first one, like I said, if you kind of visualize this line of best fit, it almost makes a perfect straight line, right? It's pretty dang close. So the fact that it's going downhill or you would have a negative slope would mean this is a strong negative correlation. The second one, if you draw the line of best fit, it also is pretty dang close. All those points are pretty close to your line. So I would say that's a strong, and since it's going uphill, or that would be a positive slope, that would be a strong positive correlation. Based on the line of best fits I just drew, what do you think how would we describe the correlation for these bottom two graphs? Any ideas? Give these a try before we go over them. All right, assuming you gave that a try. Well, first off, this one is negative because it's going downhill. But notice how spread out those points are from each other. It's not like the one above it. So we would say this is weak. It's not as strong because your points are more spread out. Like they're not all really close to your line of best fit. And then this next one, I mean, it doesn't really look like it's going up or down. It looks like your points are everywhere, or your line of best fit's almost horizontal. If that's the case, there would just be no correlation. There's really not a strong relationship between your two data points. So whatever you're looking at, it just seems like there's really not a connection between the two things you were looking at. All right, let's look at concept 3. This one, you're going to be making predictions based on the line of best fit they give you. So in this problem, it says Christopher decides to research the relationship between the length in inches, and I think I cut that off when I copied this, but this is inches on the bottom here, and the weight of a certain species of catfish. He measures the length and weight of a number of specimens he catches and throws them back into the water. After plotting all his data, he draws a line of best fit. Based on the line of best fit, what would you predict the length of a catfish that weighed 45 pounds? So the first thing you always want to look at is this an X or a Y value? So if you look, weight is here. So that is a Y value. So we're trying to figure out like what the amount of inches or what the X value would be when you're up at 45, like which would be somewhere probably off the graph a little bit. So how you can do this is you want to see what's happening with your Y values between each one of these points. So if you look from 9 to 18, it goes up 9, goes up 9. So we would do 2 more points like this. Like if I went up by 9, I would have 36. If I went up by 9, I would be at 45. So I want to see what's changing with my X values. If you look, like the X values are going up by 4. So for example, when my Y value is 36, I would have added 28 plus 4, that would be 32. And then when I do it one more time with this 45, I would have 36. So it would be 36 inches when it's at 45. And I know my handwriting here is kind of sloppy. I apologize. You might, when you get to this section, you might want to click show example, kind of see how they're drawing it out. It might be a little bit easier to see. But basically, you kind of want to see how your X and Y values are changing and increase those consistently until you get to the Y value or X value they're asking you to find. The last concept you're going to see in Delta Math is interpreting some different things from your line of best fit. There are different questions you're going to see on this section. So there's not just like a one answer I can tell you do this. You really do need to think about what they're asking you. Feel free to look at the examples, but there are different things they will ask you to think about. They might ask you what the slope represents. They might ask you what the y-intercept represents. But what you always want to remember is this is your X value going along the bottom. This is your Y value going up and down. So any X value you see is talking about temperature in this example. Any Y value you see is talking about the number of hot cocoa sold. So they ask us, what does the point 3557 represent? So remember, that's your X value and that's your Y value. So X is temperature. So it's saying at 35 degrees Fahrenheit, and Y is the number of cocoa sold. So what this is saying, at 35 degrees Fahrenheit, you would expect, or you did sell 57 hot cocos. So basically, if you have a point, that's what it's representing. And if it's a data point, that's an actual value. Like that's a point on our graph. If they're asking for a point that's on your line of best fit, remember, that's going to be a prediction. So just be careful. If it's an actual point on the graph, it's an actual value. But if it's on your line of best fit, that's a prediction. It's not an actual data point that you plotted or was from your data set. So let me know how you're doing with this. There are 4 sections in Delta Math. See how it goes. I think some might be a little bit trickier than others, but I hope it goes well. But if you need help, like I said, just ask me for any help.